I make it bigger. It is now 10. I changed it to 100. I just make it bigger. So we go into the R4 device. Interface E01. IP OSPF cost 100. Then we look at this route. If R1 goes to 2.2 now, it seems that there is only one jump. The next hop just now seems to have 2 hops. Now there is only one left in this list. Then it means that when the data passes, it goes down, because it checks the routing table forwarding. This is the one in the routing table. It matches this one. Then come back and hope it goes on, which is also equal. For the top, the packet was destined for R1 when it passed. Routing is converged like this. I hope to make the above road bigger. When replying to the packet, hope to go on. That is, when the packet comes back, make the road below bigger. Then for R1, routing is converged like this. For R2, this is how routing converges. If you want to make the cost of the path R2 larger, I should change these interfaces. The loopback port, this interface, and this interface. Since the above we changed here. Next, we will change the left interface of R3. Let's make it bigger. They are in opposite directions. We call the outgoing direction of the packet. So the direction is different. Change on R3. Interface E00. IP OSPF cost 100. Then we go to R2 to see the route to R1. Show IP route. Let me see if I changed it successfully. Haha, scared me. I thought this modification was invalid. For now, 1.1 is 2. Refresh it again. 1.1 becomes 1 article. I thought I changed the wrong interface. Okay. Not corrected. It takes time for it to work now. Just 2. Now going to 1.1 is only 24.1.1.4. Now R2 replies with the packet. The next hop is R4. It walks up. So, when data is being sent, you will find this is how the traffic goes. The return traffic goes like this. Fulfilled this requirement. Now the last one left. We now want to telnet it. Let's configure telnet first. That is, I can telnet this 2.2 on this 1.1. Then we first enable the telnet function on R2. Set user. VTY04. Up to 5 users can log in. Then we still set a password. Password Cisco. One way we'll set it up later. Transport input telnet. OK. Set up. Telnet function is enabled. After opening, let's test whether we can telnet on R1. Telnet 2.2.2.2. Password Cisco. We climbed up. It is possible to telnet. We exit. Now the last one left. Can telnet but not ping. It's actually a ping. You might say, we don't know exactly how to filter. Beginners often fall into a dilemma. When an ACL is configured. When you can't get rid of some traffic. Just configure one more. At last. A lot of rules may be entered in an ACL. Finally killed it. But I don't know which one works. Many students do this when they are beginners. It is recommended that if you are trying it out for the first time, get rid of the previous one. Then enter the new. See which one works. It is recommended that you enter an ACL in R3. Then go to filter. Filter ICMP traffic from this 1.1 to 2.2. We actually talked about this just now. In fact, it's okay for you to do it in R2. But we're usually as close to this message as possible. Don't be the last to do it. Do it before. But I tell you, You can't do it here in R1. Because a device cannot filter out the traffic generated by itself. So you guys don't do it on this device. You can choose the left interface of R2. Or the left interface of R3. Because the traffic that comes from it is bound to go down. Your configuration above is useless. This device data will be initiated by R1 later. Let's take a look at this configuration. Access list. Excuse me. I forgot to log out. Let's get out. I now enter an advanced ACL. Because we now want to match it exactly. Access list 100. Deny current ICMP traffic. From a host 1.1.1.1. Reach another host 2.2.2.2. Echo message. There is one command missing here. Access list 100 permit IP any. Don't forget this. Although today we will not demonstrate who came to visit. But this command you have to remember to enter. After configuration. The interface has not been called yet. Call the left interface of R3. Interface E00. Enter this interface. Then we call IP access group 100 in. Then press enter. Now we are done. So now we can do a demo. First check if you can ping here. Secondly, see if you can telnet. Let's look at ping first. Because we have now isolated the ICMP message. Actually, now it should be unable to ping. That is, I am now on R1 to ping R2. If so, can ping link A? It definitely works now. Because when the data goes out now, if you do not specify the source, it is the outgoing interface. So it's definitely 02 now. 13.1.1.0. Send message to R2. R2 replies with packets back to this interface. It has this route. There is no strategy for this route. Then it can reply packets. So it can be pinged. But if you add the source, it will not work. Ping 2.2 source 1.1.1.1. This doesn't work. The percentage of successful messages is 0 out of 5. None sent. I can't ping it now with 1.1 as the source. So, we test the equivalent of can't ping it, but now want to telnet it. If you telnet it directly from here, there will be problems. Telnet 2.2.2.2. You can come in too. But it's not really coming in. This is not our experimental result. In Cisco. How to specify this? How to specify from 1.1 telnet 2.2. It has some other input methods. There is an order. IP telnet source interface loopback 0. Then press enter. This sentence means, if you use the telnet function, the default source interface is this loopback port. If you do not specify the loopback port on Cisco, by default, it is still telnet with the outbound interface of the message. So if you don't set this command, go to telnet it. Its default traffic goes like this. It must be able to come. But now we want to set 1.1 to be able to telnet 2.2. But 1.1 ping fails. We have to be stricter. Although it certainly works. But I still want to emphasize. Telnet 2.2.2.2 can still come in. This is what really comes in. Telnet is a TCP-based message. It is a service on top of TCP. It is equivalent to an application layer function. ICMP is just encapsulated on top of the IP layer. It is just a 3-layer protocol. We have made a strategy for the protocol accordingly. Then you can let the data flow through this interface. It is intercepted by the ACL attached to the interface. Then this wave of message requests will not come through. The ICMP reply cannot be returned. Then the ping fails. But this is a telnet message. All other IPs are any. Other than ICMP fixed 1.1 and 2.2. Communication with some addresses such as source IP and destination IP. We released all the remaining traffic. Then once the flow is released, the result now achieved is all messages are available. Of course, telnet packets can pass through. This is our experiment. If there is something you didn't understand, you can contact my teaching assistant to get the screen recording. You can practice by yourself after class. This is our last CCNA class. Don't think this experiment is easy. Basically, all the content involved in NA is integrated. Although less equipment. But there are many functions. This is the end of our NA phase. Okay. We'll stop here. Then we also hope that students can follow us. We are ThinkMo Education. I'm Grolin Annesley from ThinkMo. I hope today's content is helpful to you. See you next class. Bye classmates.